Today we're going to be beginning our review topics before we begin the new college algebra stuff. And the first thing we need to discuss is different sets or groups of numbers. The first one is called the natural numbers. The natural numbers are also called counting numbers. These are numbers like 1, 2, 3, 4, 5, 6, and so on. All the numbers that you learned when you were first learning to count. The next group of numbers that we have is called the integers. The integers is all of the numbers, both positives and negatives, that don't have any decimals and don't have any fractions in them. So it's all the natural numbers, and then it's all their opposites, the negatives, and then 0 in addition to that. The rational numbers are all real numbers that can be expressed as a fraction of two integers. So some examples of that: negative 5 over 2, 3, because 3 can be written as 3 over 1, negative 18 over 19, positive 1/2. Any of those would be examples of rational numbers. And then an irrational number, or irrational numbers, those are real numbers that are not rational. That's the only way we define them. So in other words, they're numbers that cannot be expressed as a fraction of two integers. Things like the square root of 5. Or pi is irrational. It cannot be expressed as a fraction of two integers. Some properties of real numbers. Real numbers have the commutative property. In other words, when we think about the addition of them, if you take a plus b, that is equal to, or it's equal to the same thing, it's equivalent to b plus a. For multiplication, any number times another number is equal to those things switched around. So 3 times 4 is the same as 4 times 3. The commutative property, those things can switch around. Next we have the associative property. The associative property deals with the grouping of numbers. So for instance, for the addition problems, we've got a plus b grouped together plus c is equal to a plus the group b plus c. You can see with the multiplication we have the same thing. You have a times b in parentheses times c, and then here we have a times the group b times c, and those things are always going to be equal. We have the distributive property. We've learned about the distributive property many times, and the key thing with the distributive property is that the a distributes to the b, and the a also distributes to the c, giving us ab plus AC. Another thing that happens, and we don't think about this as often, but if you have a plus b in a group times c, the distributive property can also work in this direction. The c multiplied by the a and the c multiplied by the b. So we can see that that gives us AC plus BC. Let's get rid of these lines here. Now some terms involving negatives. We've got the additive identity, and the additive identity is a number, and we represent it with a 0, and then it has this property. Any number plus 0 is equal to that number for all real numbers a. So we think about 5 plus 0 is still 5, or negative 8 plus 0 is still negative 8. And this is the additive identity. Then we have negatives, or opposites of numbers. And we have a number, and we represent that with a negative sign in front of an a, with the property that a plus the opposite of a equals 0 for all real numbers a. And again, we know this. 5 plus the opposite of 5 will equal 0. Negative 8 plus the opposite of negative 8 will also equal 0. In order to subtract, and you learned this back in Algebra 1, but in order to subtract, we simply add the opposite of the number that we are subtracting. So instead of doing 5 minus 32, we do 5 plus a negative 32, because we have rules for adding numbers with different signs. Some properties involving negatives. If we have negative 1 times any number, you get the opposite of that number. And again, we represent the opposite of a number with a negative sign in front of the value. If you have negative 1 times the opposite of A, you get A. Got a couple of them there. If we have negative A times B, that's the same as A times the opposite of B, or that's also equal to the opposite of AB. Then if we have the opposite of A times the opposite of B, that equals AB. We've seen this rule many times. We think about if we have two negatives multiplied together, we get a positive answer. Now, one thing to be sure of is we actually don't know that the opposite of A is negative or that the opposite of B is negative. But the key thing here is that this is really negative 1 times A and negative 1 times B. And so these negative 1s, when they multiply together, they basically cancel out to just give us positive 1. If we have the opposite of a sum, just like the distributive property, this negative sign gets distributed to the A and then also to the B. So we get the opposite of A and the opposite of B. If we have the opposite of a difference, the same thing happens. The negative will go with the A, and it will also get distributed to the B, so it becomes the opposite of A plus B. Some terms involving division. When we have the multiplicative identity, that's a number, and again we represent that with a 1, and it has this property. Any number times 1 is still that number for all real numbers A. So, 83 times 1, we know that's 83. We don't even have to think about that. We learned that a long time ago. We have inverses, or reciprocals. This is a number represented as 1 over A for any A not equal to 0 that has this property. A times the inverse of A, or the reciprocal of A, equals 1. And we can think about that. This is really A over 1, so if you think about multiplying, those two values can cancel to 1s, and obviously 1 times 1 is going to be equal to 1. To divide, we're going to multiply by the inverse of the number that we are dividing by. So the same rule that we used for subtracting, we can use a similar rule for dividing. So instead of dividing by 5/8, we can multiply by the inverse, or the reciprocal, 8/5. The numerator of a fraction A over B is the A. The denominator of that fraction is the B. Again, let's get rid of this writing. Some properties for division. When we are, or these are actually divisions, fractions. So A divided by B times C divided by D, you just multiply straight across. AC over BD. Next, when we're actually dividing fractions, if you remember, instead of dividing, we multiply by the reciprocal. So you can see, instead of C over D, we multiply by D over C. And then we just go back and use the rule from number 1. For adding fractions, when you have a common denominator, notice they both have a denominator of C. That denominator stays there, it doesn't change, and you simply add across the top of the fraction. When we have different denominators, and this is where it becomes a little bit tricky, let's get rid of these arrows so they're not confusing. But we have to get a common denominator, and if you remember how we get a denominator, we figure out between this B and D what our denominator should be, and it's going to be BD. So we have to multiply this one by d, top and bottom, and we multiply this one by b, top and bottom. So you can then see that we would have d times a plus b times c. So this is just a little bit of a shortcut method for that, but it's just getting a common denominator and adding. If we have AC over BC, you think about factors. These common factors can cancel to ones, and A times 1 is A and B times 1 is B. And then finally, if A over B equals C over D, then we talk about cross multiplying. A times D will equal B times C, and that's true for any set of fractions that are equal to each other. These are proportions. Okay, terms involving order, less than, greater than stuff. We talk about the origin. This is the point 0 that separates the positive numbers from the negative numbers. Think about a number line. When we talk about the coordinate line or a number line, this is a line representing all real numbers, all fractions, all decimals, all integers. All of those things can be placed on a number line. We say that A is less than B, and we write it with A is less than, make sure you understand that symbol, less than B, if B minus A is positive. We say that A is greater than B, and again, the symbol there is going to be important. Make sure you understand that, if A minus B is positive. If you think about that, that makes sense. If 7 is greater than 3, 7 minus 3 will be a positive number. Some terms involving sets. When we talk about a set, this is a collection or a group of objects. So a set is just a fancy word for a group when we talk about sets in math. An element is just one of the objects in a set. And we can define a set by listing each element in the set. For example, we could say set A is equal to 2, or is equal to the set of numbers 2, 4, 6, and 8. But we can also define a set by using set builder notation. And we can say that set A is equal to the set of x values such that, that little line there means such that x is even and x is between 1 and 12. If you think about it, that's the exact same set that we looked at above. Rid my writing here. And I just wrote that out. You read that x such that x is even and x is between 1 and 12. So some more terms involving sets. If S and T are sets, then the union of S and T, which is written S, whoops, let's go back. This is the union symbol right here. It's like a kind of a widened out capital U. And it's the set of all the elements that are in S or in T or are in both. Then we have the intersection of two sets, S and T. This is the symbol for intersection. It's the same symbol as union, but it's upside down. So it's the set of all the elements that are in both S and T. And we'll do a couple of examples to kind of illustrate that. The empty set is a set with no elements in it, and we represent that. It's a circle or a 0 with a slash through it. So now, we're given a few sets. And the first set we're given is S, and it's 1, 2, 3, 4, 5. T is 4, 5, 6, 7, and V is 6, 7, and 8. So when we think of S union T, that's all the elements that are in S, which is 1, 2, 3, 4, 5, and all the elements that are also in T, which are 4, but we've already got that, 5, we've already got that, and then 6 and 7. So S union T is all the values that are in either one of those sets. For S intersect T, remember that's the intersect symbol, that's all the ones that are in both S and T. So if we think about S, 1, 2, 3, 4, 5, and then T, 4, 5, 6, 7. The elements that are in both are 4 and 5. So the answer to this is that S intersect T are the two values, the two elements 4 and 5. Then finally S intersect V, well, if we think about that, we've got 1, 2, 3, 4, and 5, and then for V we've got 6, 7, and 8. So when we compare these two, we notice they have no elements in common. So we find out that that is the empty set. And again, that's how we write that. It's a circle with a slash through it. All right, some terms involving intervals, and we're just about done here. An interval is a set of numbers that corresponds to a line segment. An open interval, parentheses, a to b, is all the x values such that a is less than x and x is less than b. A closed interval uses brackets on each end, and this is the exact same definition, but this time it's all the x's such that a is less than or equal to x and x is less than or equal to b. And when we talk about absolute value, this is the distance from a to 0. Remember that if a is negative, the opposite of a is positive. And this is why we talk about that, because our definition of absolute value is that the absolute value of a number is just the number itself as long as a is greater than or equal to 0. But the absolute value of a number is its opposite, not negative, but its opposite if a is negative to begin with. So for instance, when we think of the absolute value of negative 5, that's the opposite of negative 5, which is 5. Now we know that's 5 already, but we have to think about it algebraically, because sometimes if we use variables, we don't know if it's a positive or negative number to begin with. A few properties. As we talk about absolute values, the first one is the absolute value of a number is always greater than or equal to a. We know that an absolute value of a number is always equal to the absolute value of its opposite. The absolute value of a product is equal to the product of the absolute values. The absolute value of a quotient is also equal to the quotient of the absolute values. And then finally, the distance between 2 points on a number line, the distance between a and b, is just equal to the absolute value of b minus a. Your assignment for tonight that you need to start working on, and you can have time to work on this tomorrow in class and ask questions, is for preview section 2, pages 21 and 22, 19, 20, 22, 33, 36, 39, 41, 42, 47, 48, 53, and 61. And these will be collected later on in the week.